Okay, let's begin with lecture number 15. Write down the question. Find the average and RMS values of the waveforms shown below. So please draw the waveform. The waveform is as follows. This is time and this is voltage, and this is my waveform. It's a square waveform and it will repeat itself. Okay, this is 0, this is capital T by 2, this is T, this is 3T by 2, this is 2T, and this amplitude is 10 volt. What do we call maximum amplitude as? Vm. So basically Vm is 10 volt. Please note down the diagram first. Now tell me, what is the period of this signal? Yes, capital T is my period. So this is my period of the signal. Which is capital T. Yep. So let's start with the solution. So first of all, how is this V defined? I mean, this voltage V is actually 10, right? It's actually 10 volt if I am in the interval, if T goes from 0 to T by 2. Meaning between 0 to T by 2, my value of V is constant 10. Alright? And it is 0 from the period T by 2 to T. From T by 2 to T, its value is 0. So this is my definition of voltage. So please note it down. Accordingly, I will apply my integral and find the value of V average and V RMS. Got it? Okay, so let's move further. So let's start with V average first. So what is the V average formula? 1 by T integral 0 to T V of T dt. This is actually function of time. Actually this is V of T. Alright. So this will be 1 by T. Do we need to go to 0 to T? No. Because from T by 2 to T it's 0. So we can go till 0 to T by 2. And what is this? If we consider this 10 volt as Vm, let's consider this is as Vm. Okay. So what will be this? Vm, right? Vm dt. So Vm upon T will be constants, and what will remain over here? T, going from 0 to T by 2. Are you getting it? Instead of 10, I am assuming that it's Vm value, and at the last step I will substitute Vm as 10. Got it? Now solve it further. So what is V average? Vm by T, this will be T by 2 minus 0. So how much it will be? Vm by 2. And how much is the value of Vm given to us? Vm given is 10. So 10 by 2, the average value of the waveform is 5 volt. So please write down V average of the above waveform is 5 volt. Everyone understood? Any doubts? Clear it is? Now similarly find V RMS. Can I proceed? You have to be quick in writing. So let's start with V RMS. What is the definition of V RMS? We write V RMS square is equal to 1 by T 0 to T V square T dt. That's the definition. So we write 1 by T 0 to T by 2, because T by 2 to T is 0, V of T is 0. and here it will be Vm square dt. What will be for the Vm square by t, this t going from 0 to t by 2. Got it? So this will be Vm square, Vrms square, it will be Vm square by t into t by 2. That will be Vm square by 2. But this is Vrms square. So what will be Vrms? Vm by root 2. Got it? And what is Vm value? 10. So 10 by root 2 is the answer. So find out how much it is. It's 7.07 volt. Check the answer please. Yes? It's a plain and simple definition of V average and Vrms, and we are substituting and finding the answer. This is the simplest numerical in average and finding average value and RMS value. This is just to refresh your memory, that's it. I mean, these come in exam? Yes. Alright. Now I'll give you another clue. Completed everyone up till here? Okay. Now I'll give you another clue in finding the average. So write down note, write along with me this note. First, average value is equal to area under the curve. I mean, when we find the integral, we are finding area under the curve. So it's not new definition, divided by base. Got it? Area under the curve divided by base. Next, for symmetric waveforms, write down. What do you mean by symmetric waveforms? Whose positive half and negative half are equal. Okay? That is a symmetric waveform. Now, its average value is given by area of the half cycle divided by base length of the half cycle. Alright, and for asymmetrical waveform, what do you mean by asymmetrical waveform? Whose positive half is not equal to negative half. So what's the formula for average value? There it will be area of the full cycle divided by base length of full cycle. Got it? Completed? Okay. So write down numerical number 2. For today. So write down, find the average value. Find the average value of waveform shown below. So draw this waveform please. This is t in seconds and this is my voltage V. The waveform is like this. And it will repeat itself. This is 1, 2 and 3 and this value is 4. Now tell me, what is the period of the signal? 1. Why? Because after 1 it repeats itself. So this is my period t. Okay? Have you noted down the numerical? So let's start solving. You have to be a little quick. So first step is, what is t? 1 second. Second step, can you all tell me what is the value of v over here? What is the value of v? Symmetric waveform hai na? This is symmetric or non-symmetric? So area under the curve and divided by so what is area over here? 4t, correct? And divided by total base, that is 1. So it is 4t. Did you get it? Right? So this is going from 0 to t to 1. So that's it. Now find the average value. So V average is 1 upon t, 0 to t, V of t dt. Actually this is V of t. Alright, so how much is t? 1. So 0 to 1, V of t is 4t dt. What is integral of 4t? 4 out. So what is integral of t? T square by 2. Right? So this will be t square by 2, where t is going from 0 to 1. How much is this? 4 into half. And what's the average value now? 2 volt. Got it? Understanding? Now, are you following how it was 4t? Right? Now let's, if you have understood this, the next one will be simpler for you. Write down numerical number 3. Yeah. See, what is the area of this? Half into? This is not a triangle, right? No, not a square. It's not a square. So this area divided by the base, which is t. That will be 1. We'll solve one more numerical and then it will be more clear. Understood? See, you know the equation of the straight line, right? What is the equation of the straight line? Y is equal to mx plus c. So if this is a straight line, ऐसे, itna say. Now, and this value is, let's say 4. Okay, and this is time and this is your volt, this thing. So what will be the equation of this line? V is equal to 4 into x, this t. That's how you get it, and that is down. So that's how you get this. Got it? Now we'll solve one more numerical, then it will be more clear to you. So write down numerical number 3. It will be more clear in this numerical actually. Find, I have to use the black pen. Find the average value of the waveform shown. Of the waveform shown below. So let me draw the waveform. So please kindly draw this waveform, please. Okay. And it will repeat itself. So this is t by 2, this is t, this is 3t by 2. So how much is this? T by 4, got it? And this value is 10 volt. Now you have to listen very carefully how we write the, how we write the expression for this. Now what is the period of this waveform? Yes, so this is my period. Period is something from which the waveform starts repeating itself. Is my area of, let's say this is 1 and this is 2. Is my area of 1 same as area of 2? Okay. Now if I have a straight line like this, again, what is the slope of this line? Given by y is equal to mx plus c, and how do we calculate the slope? y2 minus y1 upon x2 minus x1. And what is the slope if c is 0? Y by x. Just remember these things if c is 0. Okay. Now tell me, how do we write v? V. देखो इसका y intercept is 0, right? C is 0, right? Please concentrate over here. Here C is 0. So m is y by x. What is y over here? 10. Got it? And what is x over here? T by 4. Why T by 4? Because we are counting till year to year. Area of 1. This is area of first. This line ना देखो ना ये लिख रहे हो ना, ऐसा है ना ये. Y intercept is 0. So what do we write? Tell me. V is equal to, this is nothing but my y. Let me write completed, then you will understand. 10 divided by t by 4. समझ में आया? This is same as 40 into t. Did you get it? How we got it? Now I will explain again over here. This is nothing but y. This is m and this is x. Got it? नहीं अभी भी नहीं समझा? M is this ना, this 10 divided by period, and this is y is equal to mx because c is 0. Understood now? So in the same way, last equation also we can find out. Now did you get it? Or should I explain again? Yeah? Okay. See here, the equation of this line will be y is equal to mx, but the y coordinate will be 0 over here, right? So what we have over here is m is y by x, okay? And what is y over here? Height of this is 10. And what is the period? T by 4, till here. I am talking about this cycle only. This one. Period is 0 to t by 4 and height is 10. So what is m? M will be 10 upon capital T by 4, and we have to write it in the form of y is equal to mx, right? So y is v, x is t, and m is 10 by t by 4. Got it? So please complete it now. That's it. Only if you determine this. So this is area of 1. Now write down a statement. In the interval 0 to t by 4, voltage V increases with a constant slope of 10 by t by 4, that is 40 by t. Okay, so that's why we write V is equal to 40 t by t. Got it? But since area of 1 is equal to area of 2, when we write the integral, what do we write? Now when we write V average, what do we write? 1 by t or 2 by t? See, this area of 1 is same as area of 2. So we can write twice at the average value, right? Did you got it? How it is 40 t by capital T? Now, so V average will be, instead of writing 1 by T, it will be twice by T. Why? Because area of 1 is same as area of 2. Area of 1 is same as area of 2. Now, this is area of 2, let's say. This blue one is area of 2. So, area of 1 is area of 2. So, it will be twice 2 by T integral, okay. Please complete it now. Integral 0 to T V of T dt. Did you understand why 2? Twice the area. Okay. So you can write a reason over here. Area of 1 is equal to area of 2. So V average will be 4 by T. It is valid between 0 to T by 4 only, right? Is that twice the area, but is valid between T by 4. You know, area of symmetrical half cycles we have written now, formula. What is it? For symmetric waveforms, average value is area of half cycle divided by base length of half cycle. Got it? So that's why area of half cycle is what? 40 by T into T dt. Are you following? Yes or no? So this will be 4 into 40 divided by T square, and here what is the integral of T? Let me write it one more time. Zero to T by 4 T dt. What is integral of T dt? T square by 2. So V average will be, this is 4 into 40 divided by T square into T square by 2, where T is going from 0 to T by 4, capital T by 4. So please solve this further. It will be 4 into 40 divided by T square. Inside the bracket what you will have? T square by 16 into half minus 0. So how much it will be? 4 into 40 divided by T square into T square by, I think 32, right? 16 into 2. So what gets cancelled over here? T square, T square. Find the value over here. This is 4 and this is 10. So how much it is? 5 volt. So V average value is 5 volt. What 4 by T? This? Second step you are saying? Oh, got it, sorry. See, this is twice the area, right? But this is see, what is the result what we have written over here? For symmetric waveforms, average value is area of the half cycle divided by base length of the half cycle. So what is the half cycle over there? T by 4 is T. We are calculating from 0 to T by 4. Uska half cycle kitna hai? Are you getting it? So that's why it become T by 4 by T. Did you got it? और ये twice कहाँ से आया? Because area of 1 is equal to area of 2. Forget about that. See, it came from this definition. For symmetric waveform, average value is area of half cycle divided by base length of the half cycle. Now, right now, we are only dealing with this part, 0 to T by 4. So, इसका half cycle कितना है? T by या T by 2? t by 2 is double the cycle, right? Because हम लोग right now we are considering twice the area ना, area of 1 is equal to area of 2, तो length भी तो उतना ही consider करोगे ना, this and this, because we are considering both the area now, so that why it become 2 by t by 2. Got it? Integral 0 to t by 4, instead of t it will be t by 4 here. Got it or still confused? You have understood how this 2 came? This is clear because twice the area. How this came t by 2? Because we are considering from 0 to t by 2 now. How this is t by 4? How we are going from t by 4? Why this is integral 0 to t by 4? Yeah? Yes, half cycle, that's why. See, if it was not the case, we would have written over here 1 divided by t by 4. ऐसे लिखते हैं ना हम लोग, वही हो गया ना मीनिंग, देखो इधर मीनिंग वही हो गया ना. See, we would have written 1 by t by 4 integral. If I have written this, then you would have not got why, how this has come. Actually ये reality नहीं है, the reality is this. It is twice divided by t by 2. Because अगर यही cycle रहता, if this was the cycle, then would have written it like this. Since the cycle is this, we are writing it like this. Got it? So it's the same way of writing the same thing. Not understood still? Okay. Hope it is clear now. Now next write down, next numerical. Numerical number, today's numerical number 4 now. Numerical number 4. Find the effective value, please write down. Find the effective value of the resultant current that carries simultaneously a direct current of 10 amperes and a sinusoidal current of peak value of 10 amperes. Achha, what is the effective value? Other definition? Effective value means RMS value. The other definition, other name for effective value is RMS value. Now, can anyone tell me what is the equation of I? If you have understood the statement. If you have understood writing this equation of I, then this module is you have understood it very well. What is the equation of I? It carries a DC value of 10 plus a peak value of sinusoidal current of 10. So it will be Im sin theta, right? So it will be 10. Did you got this? See, sinusoidal current is given by Im sin theta and Im value is 10. So this is, so how this looks like. This is nothing but, okay, this is pi, 2 pi, t is 2 pi and this value is 10. Got it? अभी इसका RMS square find करना है, I mean I RMS value. So please write down I RMS square will be 1 by t 0 to t I square theta t d theta. This is I of theta we can write. So write down what is t? 2 pi, right? Now to 2 pi now. 0 to 2 pi. It's a 1 period here. So this is t. So this will be integral 0 to 2 pi. What is I square theta? This is 10 plus 10 sine theta the whole square. Are you following? Now a square plus b square formula and then integral. So please start solving. So this will be 1 upon 2 pi integral 0 to 2 pi. This is a square plus b square. So this 10 I am taking outside, so this becomes 100, right? So it is nothing but 1 plus sine theta. See, this I am taking 10 out. So this becomes 1 plus sine theta the whole square. What is the value? 1 plus 2 sine theta plus sine square theta d theta. Can anyone know sine square theta is what? Sine square theta is 1 minus cos 2 theta by 2. So please substitute it over here. Please continue solving this, don't just look at it. This will be 100 upon 2 pi. This will be, okay, let me write integral one more time. 0 to 2 pi 1 plus twice sin theta plus 1 minus cos 2 theta by 2 into d theta. Got it? And now you open the integral. So I square RMS will be 100 upon pi. So integral of 1 will be theta, right? Minus, what is integral of sine? Minus cos, right? This will be theta by 2. What is integral of cos? Sine. So minus sine 2 theta by 4. By 4 because this 2 also comes. And here theta goes from 0 to 2 pi. Come on, write down or you will be left out behind. So this is 10 by 2 pi. First substitute 2 pi everywhere. So 2 pi minus cos, where it is 100 by 2. It was 100 by 2 pi only. Cos 2 pi plus 2 pi by 2 will be pi minus sine 4 pi by 4. Okay. Then minus, we will substitute 0 everywhere theta ki jagah. So 0 cos 0 plus 0 minus sine 0 by 4. Yeah. Now tell me what is cos 2 pi? No, don't believe yourself. Believe the calculator. This is 1. What is sine 4 pi? This is 0. Cos 1, cos 0, 1 and sine 0, 0. So now substitute carefully. So it will be I RMS square 100 by 2 pi. What will be internal? This will be 2 pi minus, this will be 2, right? Plus pi, this is 0, this is plus 2. Plus 2 now? Yeah, that's it. So what is this number? 100 divided by 2 pi into this 2 and minus 2 will get cancelled into 3 pi, right? So this will be 300 divided by 2, which is 150. So this is IRMS square. So what will be IRMS? Square root of 150. How much is that? 12.25. Yeah, that is the answer. See, once we get the mathematical equation to solve integral, then we have to go on solving. I'll keep this for 20-30 seconds more. It is visible? Got it? You got the same answer. Root of 150 is 12.25. Okay, please next. RMS value write down. Similarly we have written average value of the symmetric waveform. Similarly we have RMS value of symmetric waveform. Write down the formulas. Is equal to square root of area of, I am writing half cycle as HC, area of half cycle divided by base length of half cycle of squared waveform. Similarly, RMS value for asymmetric waveform is given by square root of area of full cycle, FC I am writing, of squared waveform divided by base length of what will come, base length of full cycle. Last time we have written average value of asymmetric was full cycle or half cycle? Full cycle. I will verify this point. So just circle it and keep it. Now write down numerical, not numerical, one example. Find average value of sinusoidal AC wave, where I am sin theta. See here, please listen carefully. This is a slightly confusing concept. Listen here. I have already told you average value of this waveform. Let me show it to you. Please concentrate over here or else you will get confused. Now what is the average value of this waveform? This waveform. Average value is 0, but it is 0 over the complete cycle. Barabar hai? If we consider only this cycle, it is 0? No. So that is what we are doing. We are only considering half the cycle. Got it? So write down over here, I average over the complete cycle. The important word is complete cycle. So I average will be 1 upon pi, right? Here the period will be pi. Let's consider 0 to pi I theta d theta. So I average will be 1 upon pi 0 to pi. This will be I am sin theta d theta. This will be I am by pi. What is integral of sin minus cos, where theta goes from 0 to pi. Got it? So what will be I average over here? I am by pi. This will be minus of cos pi plus cos 0. What is cos pi? Cos pi is minus 1 and cos 0 is 1. So what you get over here? I am by pi. This will be 1 and this will be also 1. So that will be 2. So it is 2 I am by pi. Okay. So I average is, calculate 2 by pi, 0.637 times I am. Got it? if you consider only the half cycle. If you consider full cycle, it's 0. But if you consider half cycle only of sinusoidal AC waveform, then it will be 0.367 times Im. Got it? Now calculate RMS value of the same thing. Completed this much? So write down example number 2. RMS value of sinusoidal AC waveform. Anyone knows it? Can anyone quickly calculate this value? IRMS square will be, again right now we use that same technique. What technique? We find it over the half cycle. So 0 to pi I square theta d theta. It will be 1 upon pi 0 to pi Im square sin square theta, or else you can wait, no need to write this, only write the final form then. So this is Im square by 2, no, Im square by pi. What will be integral? What is sin square theta? 1 minus cos 2 theta by 2 into d theta. So this will be Im square by 2 theta by 2 minus sin 2 theta by 4. Integral going from, limits going from 0 to pi. So IRMS square will be Im square by pi into pi by 2 minus sin 2 pi by 4 minus 0 minus sin 0 by 4. So what is sin 0? 0. What is sin 2 pi? 0. So what is IRMS square? Im by pi into pi by 2, right? So this will be Im square by 2. So IRMS will be Im by root 2. This relation you need to remember. IRMS will be 0.707 times Im. Got it? Understood? Now this equation will be utilized in other form. They might not directly ask you this, but the result of this is important. This is over the half cycle. Now write down numerical number 566. Numerical number 6 now? Yeah, 5. Completed up till here? So write down numerical number 5. The equation write down the equation of an AC current is I equal to 62.35 sine of 323t amperes. So we need to determine first maximum value, second frequency, third RMS value. Please note down, it's an important numerical. Next average value, next form factor, next crest factor. So this form factor, crest factor we are hearing for the first time right now. So this numerical is important. So let's solve it head on. So what is the standard form of I given by I equal to Im sine omega t, right? So tell me what is Im value from here? Im value is 62.35, right? This is Im, right? Amperes. So this is the max value. Acha, you need to find a frequency. So what do we do? What is omega over here? 323, and omega is 2 pi f. So what is f? 323 divided by 2 pi. How much it is? Calculate. It is 51.41 hertz. So please note down this. This is the frequency. Third, next point. अच्छा चलो, tell me what is the RMS value? तो तुम बोलो कि RMS value क्या है? ये Im by root 2. And what is Im? I average value 0.637 Im. These are formulas which you need to remember. That's why we solved it. Got it? So write down directly IRMS is Im by root 2. That's why we can directly write now. What is Im? 62.35 divided by root 2. How much is that? 44.08. Please check. Okay. Next, what is average value? 0.637, which we derived today in example number 1, times Im. Now don't put I average 0 and put it in the exam. I have already explained how. So multiply this 0.637 times 62.35. How much is this? 39.72 amperes. Now, do you remember the formula for form factor? Yes, it's IRMS divided by I average. Please substitute over here. IRMS is 44.08 divided by 39.72. How much is that? 1.11. Please check the answer. And last one is Crest factor. What is the formula? Maximum value upon RMS value. Maximum value is 62.35 divided by RMS value is 44.08, and this is 1.414. Please check. That's correct. You see how simple the numerical has become. NATO average value you need to calculate. Now we directly using the formula. Got it? Yeah? Completed everything? Now numerical number 6 last for the day. All the values you have got? Okay. Write down. So this will be completing around 2.1 module with this numerical. So write down numerical number 6. A non-sinusoidal waveform a non-sinusoidal voltage, has a form factor. A non-sinusoidal voltage has a form factor of 1.2 and crest factor of 1.5. If the average value of the voltage is 10 volt, find RMS voltage to maximum value. Now tell me what is given data. What is given to us? Form factor is given 1.2, crest factor is given 1.5 and average value is given as 10 volt. And what are we supposed to find? VRMS and VM. So how will you find it? First, what is the formula for form factor? VRMS upon V average. So from here can we find V average? Form factor into V average, that is 1.2 into 10. How much is it? 12 volts. See, simple. 2-minute numerical. Crest factor is what? Peak value divided by RMS. So VM will be crest factor into VRMS, which will be 1.5 into VRMS is 12. So this is 18 volt. Did you get it? That's it. That's the end of numerical. Okay? Got it? Now, before I leave, I'll teach you one concept in calculator and go. Rectangular to polar and polar to rectangular. So open your calculators, please. So first write down, this is very important now. We'll go polar to rectangular. So polar form is V theta and this is A plus JB. Okay. So now I have 2 minutes, 11 o'clock. मुझे दे देना. Write down this V 6.916 angle 26.2 degree. So I want to convert this into rectangular. How will I do that? In your calculators you have REC, rec written, right? Can you locate REC, rec? Yeah? So press shift rec and write here 6.196 comma 26.2. Did you find that? Shift rec or something, shift rec, na? Does the rec comes? So press shift rec in your calculators and type this 6.196 comma 26.2. What do we get? And press enter. Shift rec enter this number as 6.196 comma 26.2. What do you get? Huh? 5.55 and 2.73, right? J. You all must be getting I there. Huh? Huh, that's fine. So it is in this form. So that means this was in polar, this is in rectangular. So this is in a rectangular form. Did you get it? How to convert polar to rectangular? Press shift rec and write the answer. Now write down rectangular to polar. Rectangular will be A plus JB and here it will be V theta. So rectangular is given as minus 375.87 minus J 136.81. Don't worry about it. Press rec polar. So use your calculator and press shift polar. Did you get POL? Enter there minus 375.87 comma minus 136.81. How much will you get? V as 399.99 and second will be minus, right? 159.99. So that is this. This is in polar. So next time we will be solving polar and rectangular coordinates conversion and numericals related. Okay, so please practice this. Okay, and we end the lecture now.